All right, we're on lesson 4 of unit 3. We're almost through it. We have one more lesson after this together before we're done. So, we're still in parent functions and transformations. Make sure you include the date. We have lesson 3-4 today, vertex form of a quadratic function or equation. These mean the same thing here. Our objective is to graph quadratics in vertex form. So, remembering what shape a quadratic makes, it does make a U shape. We're going to take a look at vertex form of a quadratic. And it's very similar to how vertex form of an absolute value shows us transformations. The same thing is true for vertex form of a quadratic. It shows us transformations of the parent function of a quadratic function. And so vertex form has a formula, and we're going to write this down. The formula for vertex form is f of x equals a times x minus h squared plus k. Now remember, quadratics have the squared. That's what makes that U shape. There are some key features to vertex form, and the reason that vertex form is useful is because we can just pick out the vertex. Our vertex is right here, opposite h, comma, k. H, comma, k, and just remember that this means opposite. Opposite h. In here my h is negative, and in this example for my vertex, the h is positive. The axis of symmetry, well, the axis of symmetry is the x value of the vertex. And so our axis of symmetry is x equals opposite h. Again, this is opposite h. Super important to remember that. Our a value is special as well. Our a value determines the width of the parabola. Kind of like slope a little bit. I mean, it's different because these aren't straight lines, they're curved. This is just going to determine the width of that opening. Determines the width of the parabola. Okay. What's useful about this, again, is it shows us the transformation compared to the parent function. It also allows us to just, boom, see the vertex and then put it into our table. So what we're going to do, very similar to how we compared the parent function of absolute value to other functions, we're going to do the same thing for quadratics. Our same transformation rules apply. And so I'm going to use those same colors that I did when we did our absolute value function notes. Okay, so I've got those 4 colors. Pink was the horizontal shift, blue was the vertical shift, our green was stretch and compress, and orange was reflection. So taking a look at number 1. Alright, so there's no parentheses, which means there's no h value here. We just have this positive 9. And so that is our k value, which is a vertical shift 9. Shift up 9. Taking a look here at number 2, same thing here. We don't have any parentheses, so there's no h value here with x, and we have minus 2. So that again is a vertical shift down 2. Now comparing number 3 to the parent function. All right, here we have that negative out in front. So that negative is our reflection. And we do have a number inside of our parentheses here, so that's going to be our opposite h. So remember, our horizontal shift is a little counterintuitive. If we see a plus 5, it means it shifts left 5. So shift left 5, and then reflect across the x-axis. Taking a look at number 4 now, what transformations do you see applied here? So we've got our horizontal shift inside the parentheses, and we've got our vertical shift outside the parentheses. opposite h, so shift right 4, and shift down 1. Okay, number 5 and 6. I want you to try those ones on your own, pause the video, and then press play and see how you did. All right, so that 1/3, that A value, represents our stretch and compress. So this would be compress by 1/3, and then shift up 2. For number 6, we have that, ooh, I forgot something here. Oh, it should be orange. So we have reflect across the x-axis because of that negative. We've got to make sure we're labeling all of them. Then we have stretch by 2. And then we have left 4. All right. So, again, vertex form shows us the vertex. Just boom, we can look at vertex form and pick it out. So we're going to now practice graphing in vertex form. So we're going to be given a quadratic in vertex form, and it wants us to give the vertex an axis of symmetry and then graph the function. Now we aren't going to be able to get away from tables for quadratics, just like we were with absolute value, how we could just use a slope. It's a little different. We still need a table. But our vertex is, boom, available for us right away. So give the vertex. Remember the vertex is opposite h, comma k. So h, k. Opposite h is a positive 2, and k is a 3. So our vertex is 2, 3. Our axis of symmetry is x equals, so I'm going to abbreviate this, axis of symmetry is x equals opposite h. So x equals 2. That's going to be that vertical line that will split the parabola into 2 equal parts. Now I still have to make a table. So I'm going to make a table and I'm going to place the vertex in the middle row. Now my vertex is already evaluated for, so that takes a step out for me. So 2, 3, and then I'll number up and down, 3, 4, 1, 0. Now, when I plug in these values, I'm going to plug them into this function here. And so using my calculator, I'm going to substitute a 0 in. So 0 minus 2 squared, I'm putting that in parentheses just like I see it in the function, plus 3. And I get 7. Now I'm going to type in a 1, and I get 4. Okay, I've already figured out my vertex. It's already there for me. So now I'm going to skip to 3. Now, because the vertex is a turning point, what should we expect this next number to be? It should be a 4, and it is. And so this next one is 7. Now we're going to graph. I like to, especially when we're dealing with vertex form, I like to plot the vertex first. So remember, this is our vertex. So 2, 3. Then I like to do the other ordered pairs. So I'll go down first. So 3, 4. 4, 7. And then on the left side, 1, 4, and 0, 7. Keeping in mind this is a U shape. And boop, and boop. Put our arrows. Now if we were going to list domain and range, the domain of a quadratic is always and always what? Negative infinity to positive infinity. And then our range is always bottom to top. So our bottom is our y value of the vertex, which is 3, comma, arrows up top means positive infinity. All right, we're going to do another example. I'm going to turn my page and I've got it already set up. So make sure you're pausing the video if you need to catch up on writing this stuff down. I had the notes already pre-made here for this one. So we have 3 examples here on the back that we're going to take a look at. F of x equals x squared minus 4. So again, first step is to identify your vertex and axis of symmetry. Now because we don't have any parentheses, there's no h value. There's no h value for this. So we just make it 0. So h equals 0. So for the vertex, opposite h, well, 0, comma k, which is negative 4. So this is our k value right here. Our axis of symmetry is x equals opposite h. So x equals 0. Now we're going to place that vertex in the middle row of our table. So x, and then f of x, 0, comma, negative 4. We're going to number up and down. So 1, 2, negative 1, negative 2. And then we'll evaluate the function for each of these x values. So we've got x squared, so negative 2 squared, always evaluate with parentheses, minus 4, we get 0. Now if I sub in a negative 1, I get a negative 3, and then negative 4. Now I'm going to sub in a positive 1, and I get negative 3 again. Sub in a 2, and I get 0. Now that my table is complete, I'm going to graph this. Again, I like to graph the vertex first. It does not matter which point you plot first. So 0, negative 4 is my vertex. And then I've got positive 1, negative 3, 2, 0, negative 1, negative 3, and negative 2, 0. Negative 2, 0. I'm going to make my U shape. Put some arrows. Our domain, well, left to right, negative infinity to positive infinity, always for quadratics. And our range, bottom to top, so bottom is negative 4, and top is infinity. The next two examples we're going to look at are inequalities. And again, pause the video if you need to write these down and get your graph paper taped, or if you're using your own graph paper. So again, we want to find the vertex. Steps are all the same. We just have the shading and the dashed and solid lines to think about. So our vertex is opposite h, and then there's no k. So k equals 0. If ever we're missing a value, we're just going to put a 0, unless it's your a, because that's a coefficient. We'll make that a 1. So h is negative 4, k is 0. So opposite h would be a positive 4, comma k, which is 0. And our axis of symmetry formula is x equals opposite h. So x equals 4. Now we're going to put that vertex in the middle row of a table and evaluate. So 4, comma 0. Then I'll number up and down, so 5, 6, 3, 2. And we're going to plug those values into our function here. So 3 on the outside, parentheses, 2 minus 4. Close up those parentheses, squared, and we get 12. Okay, so now I'm going to plug in a 3 instead of a 2, and we get 3, and then 0. If I plug in a 5, since the vertex is my turning point, I should expect this to be a 3, and it is. And then if I plug in a 6, I should expect this to be a 12, and it is. All right, I like to start with the vertex. You don't have to, but I'm going to plot that first. So 4, comma 0, and then 5, comma 3. I don't have room for 6, 12 on this coordinate plane, so now I'm going to go to 3, comma 3, and then make my U. Now, because this is an inequality, I have to consider, is this a solid line or a dashed line? Looking here, that's less than, so it's going to be a dashed line, and it's below. Dashed and below. I spelled dashed wrong, so I'm just going to forget about it. All right, so a dashed line. So we're just going to carefully draw this dashed line here, make this U shape, plop those arrows on the ends, and then since it's below, it's everything underneath, including all of this over here, everything underneath that absolute value, or everything underneath that quadratic, that parabola. One more example. f of x is greater than negative x squared. So, vertex, opposite h comma k. Well, there's no h and there's no k. So this is 0, comma 0. No h, no k, they're both 0. Our axis of symmetry then is x equals 0. And so now we're going to make a table. Okay, 0 in the middle, 1, 2, negative 1, negative 2. If I plug in a 0 into this function, let's see what I get. Negative, in parentheses, 0 squared. I'm going to get a 0. Now let's plug in a positive 1. I'm going to get a negative 1. Let's plug in a 2. I'm going to get a negative 4. Let's plug in a negative 1. I get a negative 1. And if I plug in a negative 2, I should expect to see a negative 4. Yep. Now we're going to just plot all those points. Again, I like to start with that vertex, 0, comma 0. And then negative 1, negative 1, 1, negative 1, 2, negative 4, and negative 2, negative 4. And we're going to take a look at the inequality symbol. It is greater than, so a dashed line. Again. And since it's greater than, we're going to shade above, which is everything above our parabola. All right, guys, we have gone through the basics of graphing absolute value in quadratics. We have one more lesson of this unit. Make sure you're asking for help if needed and that you're bringing your questions with you to class tomorrow.